Hi everyone, welcome to the lab session of on social engineering. So today we are going to discuss three things. The concept called USB baiting, wherein you basically put a malicious file in a USB and then pass it on to for others to pick it up. Maybe in a parking lot you can throw it, and just because of the benign behavior of a person to have a curious behavior to know whether a particular device can be useful to the person or not, they can pick it up, or you can uh, while actively interacting with the target or a victim, you can actually pass on the USB. Then we'll discuss concept of farming, wherein I said that uh, a duped page is shown to a user. If a user tries to log in into some kind of a form by giving user ID or password, then that can be captured, and uh, the user is then redirected to a valid website. Okay, and then if we are left with some time, then we'll discuss encryption as well, as we discussed about it in the last class, right? So let's get ahead with it. Current environment that I have is like I have a Windows machine. Okay, it is there on VirtualBox. Uh, the scenario is that first we will create a payload using MSF Venom, and then we will put that payload on the USB, and then we'll attach that USB to this window machine and copy that file. Okay, and then we'll start off a handler using Metasploit. Okay, wait. Okay, so as far as MSF Venom is concerned, okay, say you want to create a payload. So this is the command which is shown on the screen, wherein you are actually trying to create a payload using reverse TCP staged payload. Then because I have the VM VirtualBox on this machine with Windows on it, the interface that I have on this machine is this IP address that is shown here, 192.168.56.1, and we would be listening on port 4445. The type of file which will be created is exe, and the architecture is x64 for the target, and the output file that will be created with the name of awesomegame.exe. Okay, so let's do that. I'll just press enter here. So if you are logged in as root, you don't have to use the word called sudo. So it takes a little bit of time, not too much, and it creates a very small file. Uh, let's see, so that it can be packed up easily in a USB. So as you can see, the payload size is only 510 bytes. Okay, and the final size is 7168 bytes. Okay, which is quite small, right? Uh, I'll just plug in the USB to this machine. Okay. I have a USB, so I have plugged it in. Okay, so I can like create some files here. Okay, say I create a empty file. Okay, so it's there, and similarly, the payload that I created, it's in this directory. So So let me open that and copy it on the USB. Okay. I'll just copy this and I'm pasting it back. Now, as you can see, like right now it's been named as exe. You can actually change the extension if you want, thinking that probably if I copy it on the USB and when I plug that USB on the victim machine, it won't be detected. But usually it gets detected, okay, by the Windows Defender or the antivirus engine that is running on it. And they might not let you execute or even work anything with this or rename this file, because that is immediately detected. So that I'll show it in the end. First, before plugging it in the Windows, let me just switch off the Windows Defender and the firewall in it. Okay. Just go to Windows Defender firewall. I'm turning it off. Okay. Then the antivirus. This is the like virus threat and protection. So I'm switching off the real-time protection and tamper protection. Okay. Now, the malicious file is there on the USB, which is attached to the host machine. Okay. And the OS which is there on the VM is the guest OS. So I'll just unplug it first and then replug it. So I can see that this particular exe is there. Okay. Now I'll go to the VirtualBox settings and I'll ask it to read, attach the USB. Okay, so you can see this file is there. Let's copy it on the desktop. Okay, so generally this won't happen because as soon as you plug in the device, peripheral device, what will happen is like the antivirus engine which is running will immediately remove it and probably put it in some kind of a vault by giving you a notification that it has been detected that it has some kind of a virus. Okay, so you need to take care of that. Now, for executing this payload here, we need to start off a handler so that when we execute this exe in Windows, we should be able to connect. This should be able to basically connect in a reverse way to the listener that we would start. Okay. So now I am on Kali. I've cleared the screen. Okay. Let me see if the Metasploit database is there. Yeah, it's already started and it's configured. Now I've given the command to start Metasploit. So please bear with the slow speed here because the machine does not have enough RAM for it to process commands in a fast way. Okay, just clear it. Now we'll use a multi-handler. Now imagine that we scattered the USB. Someone picked it up and doesn't know that there is. Like we could actually use an exploit kit and change the icon of the file, make it a little, you know, enticing for somebody to open it. And this payload could be part of some kind of an image of a car or a bike. You know, usually people are interested to open images. So, but here, just for the demo, we have named it as exe. Now, whenever normally in an IT department or when people are educated on these things, as soon as they see an exe and they don't trust it right away. Okay. So for the demo, I've just named it as exe. So I'm using command use the multi-handler. Okay. Now we will set a payload, which should be the same payload. Okay. With which we created in that particular file, .exe file. Okay. The handler should be related to that payload itself. So as it is Windows, x64 interpreter, reverse TCP. Okay, let's look at the options. So we'll change the local host. Why? Because let me show it to you. So on VirtualBox, we want to give this IP on which the payload would connect back to us in a reverse way. Okay. And for the port, we'll give 4445 because while creating the payload, we gave local port as 4445. It's there in the history of the command, so it's okay. So let's use the command set localhost .1. Then we set the port. Ensure that the firewall on this machine is not there. If you are trying the same thing within a VirtualBox and your own local PC, but let's say if you are trying on some other environment, then ensure that the firewall is configured to receive TCP protocol on this particular IP and the port that you give. Okay, now I'll clear the screen and we'll again say show options. And as you can see, the values are already there. They are present now. And now we can run the exploit. Okay. So you have to start the listener first, so that when over a due course of time, when the person who has actually copied the file into the PC executes, you should get a meter protect shell. Okay. So as you can see, the reverse TCP handler is running on this IP and the port. Now let's go to the victim machine, and we'll just execute it. Okay. So that small spinner was there with the mouse cursor. It is gone. So I'm pretty sure that the handler would have started and would have received a meter protect shell. Okay. So now the PC is on, the user is using the PC, and you have actually acquired a meter protect shell on it. Means you have set up a initial foothold. Okay. So let's see what all we can do with this. So we type help. So because it is Windows, so there are a lot of options. Okay. Yeah. One most important thing is that if you will look at the process table, okay, let's use that command first. So I'll just look at the process table by entering ps command, and then you say get PID. Okay. So our process is on the remote, I mean on the victim machine, the process is running under this ID 5660. So when you see in the process table, the leftmost PID is the one that it refers to. Okay. And this stands for parent PID. So let's see where is the process. It's with 5660. So you can see that it is running with this name as the user who is logged in. Okay. And the file is actually kept on the desktop. Now important thing is that just because this exe is not known to a user, or any software that monitors the process table, it might clean it up. So it's best to hide this payload or migrate this payload to something which looks not malicious to the user, or somebody who's manually scanning, or any software that is scanning. And to hide this thing is for hiding this thing, it's best to migrate on this process to explorer.exe. Okay. Because explorer.exe is the one which manages the Windows desktop. Okay. So let's see to which process ID will migrate it. Let's search for explorer.exe if it's running. Yeah, see, it's running under this ID 344 or 3444. Sorry. So let's migrate to 3444. Okay. So now if you look at the process table, okay, you won't find awesomegame.exe because it's hidden now. It's not there. Five something 660, right? It's not there. Okay, so let's see now what all we can do with this. So we can actually try to elevate our privilege if at all administrative user is there on it. Okay. Or we can get the user ID, the user that is running. Let's try to capture some keystrokes. Okay, yeah, these commands actually look quite interesting. Okay, so let's capture some keyboards, keystrokes. So we say key scan, start. So now the keystroke sniffer is on, and if the victim is going to say work on some kind of a text file, let's say, let me just search for a notepad. I'm there on the victim machine now. Okay, let's check the notepad. My super secret message. Okay, so what you can do is like it would be in the MSF console, in the interpreter shell. Let's say at some point of time I want to dump it. Okay, then you can say key scan dump. Now you can see the message that was typed in the notepad is actually captured. Okay, now similarly we can do other things. Let's try to capture the screenshot. Okay, well, let's first stop this key scan. Okay, no, clear command is not there. So what I'll do is like whatever is the state of the desktop of that machine, let's capture it. Okay, screenshot. Yeah. And there is something called screen share also. We'll try that also. Okay, so this particular JPEG is stored on our local machine with this file name. Okay, the screenshot has been captured from the victim machine, has been stored here. So we can have a look. Yeah, see, the screenshot has been captured from the Windows, and we can actually monitor by using the command called screen share also, the activities of a user. So let's see, screen share. So in the same folder, what it has done is like it is streaming it. Okay, the activities it will stream. Let me see how I can show that to you. So we'll open this HTML. Yeah. So here the status, it shows as the status is target IP is also there. Okay. With the start time, and then let's change something on the victim machine to see whether it is actually playing or not. Yeah, so it has some lag, but it is able to let's browse some files. Let's say the user is browsing some files. See, on the left hand side it is streaming that particular video. Okay, so that way you can monitor a victim. So maybe someone is looking at their own pictures, or maybe looking at the files that they have downloaded. Yeah, this folder is empty actually, and maybe they are doing something with the network. Okay, so like this you can monitor the activity of a user. Okay, so I'll just close this. Okay, in the background. Okay, so this was all about USB baiting, that we infected a file. I mean, we created an infected file, we kept it on the USB, and we waited for the user to plug it in. But before the user plugs it in and uh, does something with the file, we have to uh, start the listener at our end before that. Okay. So the next concept that we are going to discuss today is farming, which stands for like let's create the user will actually navigate to some kind of a false website and will enter the details, and but that is done with the help of another tool which we call a social engineering toolkit in Kali. So let me stop this active session. Okay, and we can eject the USB also. Okay, let me enable this firewall thing. Okay. Someone sent a chat message, right? I need to look at it. I'll just enable this real-time protection and the firewall. Okay. So I don't know when the next scan will be conducted by the Defender, Windows Defender. So let's see if during the course of our discussion, if it detects it, it's fine. But maybe that tactics can be used as in by disabling antivirus and firewall and all that, and then re-enable it so that user doesn't come to know that some suspicious activity has happened. So let's first take the concept, understand the concept of farming. Okay, so we go to SCT, and with this command SC toolkit, you can actually start the tool. I'll close this MSF minimum tab. Okay, so this is on the screen. If you see, this is uh, social engineer toolkit. It's a very nice framework developed by Trusted Security, Trusted Sec, and it's a framework that has been created by these people for pen testers. Okay, so let's choose the option 1 to do a social engineering attack. Then what kind of an attack vector we want to use? So we want to use the use case that we are discussing is the one that we are using, website attack vector. Okay, and in that, what we want to do, we want to harvest the credentials. The attack method that we want to use is credential harvester. Okay. So we'll press option 3, and you can actually clone a site with this utility called site cloner. So as of now, for the purpose of this demo, we are going to use some existing template. Okay. and that this is also going to ask you the IP on which it has to give you or report it to you, and saying that which particular IP should be able to capture the post requests. Okay, so I'll just say give the same IP which we gave it in case of MSF Venom. And once we give that IP, it would ask you what kind of a template you want to use. So we can use a Java required, notification that comes if the Java is absent. So that is the one that is usually appears in most of the times, like when the Java gets needs update, or it is not enabled, or it is not installed. Okay, and there is a Google and Twitter template which is already there. So in this particular example, we will use Google. Okay. So as soon as we do that, it would start a you know handler like the one that we had in MSF console. Okay. So this credential harvester attack is running, okay, on port 80 of our local host. I mean the host system on which the Kali is there. Now on the victim, if I try to browse, let's use the browser, and we would give that IP. Now you remember I explained you a term called typo squatting, wherein a particular link can go as part of an email message or an SMS, wherein you can dupe a user to click on a link. So you can be as creative as possible, but here we are just giving the static IP in the URL. So if you send static IPs in the URL in your emails, user might get suspicious of it. Okay, so but for this demo I have kept it just like that. Yeah. So once you give that IP, okay, in the browser, or the URL that you have actually sent to the user, it would actually show you this kind of a page, which is usually shown to the Google user, right? Google users who want to log in. Yeah. So this looks like a real Google page. So like it's very difficult to spot any kind of an error or suspicious thing in it, right? So let's you can give some email and my password. It does not have any validation on email names. Okay, so when this kind of a page is shown to you when you're browsing, and first thing that should raise your concern is that it is not secure, but you can use SSL and HTTPS to make it secure and make look more legitimate. And it is not actually giving you uh, any validation on the correct email address, whether it is wrong or right. But a benign user would probably miss these things. The person would not come to know, right? And when someone clicks on sign in, this particular page will redirect the user to some kind of a valid page. Now, which page it needs to redirect a user can be configured in the tool itself. I'll just show it to you. So you can actually, in one of the messages, you can do a lot of configurations. So you can say mention where the harvester should redirect the user, and you can change these variables like URL and the redirects. Okay. So, but because it was listening on the post requests, so it has captured the email and the password. Okay. Now here we are actually connected with a host only network adapter type using a VM and the machine. But maybe in real case scenario, you will have to probably host this thing on a legitimate looking web server on the internet. if as part of pen testing you're doing it. And then probably to get a this kind of a handler on your local machine, you will have to do some port forwarding, okay, to the public IP that is given. Maybe you'll have to configure and do port mappings in your router, so that you need to take care. Okay, but for learning purpose, you can like do this thing, like the one that I've showed it to you. So we still have like 10-15 minutes. So I'll give you a small demo on how to encrypt files using GNU-PG, the GPG utility which is there in the Linux. Okay, there are some notes that I have prepared for the same, some steps, and I'll walk you through that. Let me first close this VM and this handler. Okay, so by using 99 option, you can actually go back to the main menu in SCT, and I'll just close the VM. So I hope that it was useful. And yeah, I missed on because we have less time. I could have showed you the demo of that how the file actually does not get copied in case the Windows Defender and the antivirus is there and activated. So if you try that on your own in your own PCs, or try that in a virtual box or a VMware. Okay, don't try to execute such exes or such malicious files and spoil your working laptop if you have. I'll just close it. And you can also try that in lab. Please ask Vikas to give you the access to the lab and you can try that out. Okay. Or you can write to customer support also. Okay. So I have these notes. We have a chat message. Customer support is customer support at stupidskills.com. It's an email. Uh, it's there on the website also. Okay. Then what's the difference between a payload and a virus? So a payload is a part of a virus. Okay, virus can do a lot of other things, right? So the activity that what we have done, like we were looking at the screenshots, we were looking at screen shares, you know, we were capturing. So these all the activities are packed into as part of a software. Okay, so that software is virus or a Trojan or any other malicious software. Okay, I hope that answers it, Rahul. So payload is part of that, right? If you remember in one of the initial sessions, I explained you the difference between an exploit and a payload. So both exploit payload usually are prepared, and then other commands are there, and they all become part of virus or a rootkit or a Trojan. Okay. Yeah, so there are two types of encryptions you would normally hear about. and one is called symmetric and one is called asymmetric. So let's say if there are two users, like sender and a receiver, and they have before communicating among themselves, they have actually shared a password, and only they both know, or anybody, and as many as number of participants who are there in the communication, they before practicing encryption, they already know the password with which they have to decrypt a file. So what is encryption? It's like you try to hide your message in a way that the person who doesn't or is not aware, and the information which is not meant for the other person should not be able to see that thing, see that message. So it happens in case of protocols, it happens in case of files, it can happen in case of any other media. Okay. So here we are going to discuss that how to encrypt a file, uh, a text file, right, and pass it on to between senders and the reader or the receiver. So what we are going to do, we'll create a file first. Though this is not part of social engineering lab, but I'm covering it because we have some time left, and it was also said in the chat yesterday that someone wanted an example. Right? Okay, so let me take this command from the PDF. Okay, so I'll just use copy paste here. I think it's not letting me do that. Okay, let me hello echo hello. So what we are doing in this command, we are like using the command echo, and we are redirecting the output to a file called greetings.txt. Okay. I think I should have some more where I can copy paste this. Okay. Yeah. So we are discussing symmetric encryption first. So let's use if GP. Let's first check that whether GPG is there in your machine or not by using GPG, and you can say version. So it should be there, and it should be able to use these public key algorithms and these ciphers and the hashing algorithms and comparisons. If it is not there, then you can actually search for it with the apt, and you can install it. Okay. So it's there. For me, it's installed. If it is not installed and it's not mentioned here, then you can actually install it with sudo apt install gpg. Sudo apt install gpg. Okay. So we have created a file. Let's use a command to encrypt it with a password. Okay. And say this particular password is not known uh, to anybody other than who is actually sending and who is receiving. And this is called when the password is known to the parties. Okay. Then it is called symmetric encryption, symmetric cryptography. So I'm giving my password as password, passphrase, and I'm using option symmetric, giving the file name that I want to encrypt, and I want to create this output. Okay. So now you can see that this file is created. Okay. Greetings.txt.gpg. If you try to have a look at this, probably you won't. It won't make any sense. Okay. See, it looks like this. Some garbled kind of a message Even the text editor will not be able to open it. So it would ask that should it was not valid and all those things, right? So if someone takes or have an access to this file, they won't be able to see what is there in this file. Okay. Now, let's say on the other end, when a person wants to open it, then he has to use this command. Okay, so we give, no, this is not the one. Okay, so we say that we are outputting the actual or the message which is in clear text. We are going to write it in a file called greetings1.txt. And because as a receiver, right now I know the passphrase, and I would use option called decrypt, and I will give input as the file which is in encrypted form. Okay. So as soon as it decrypts, you will be able to see a new file, which is greeting1.txt. Okay, here, and then you can open it, and then you can read the message. So this is symmetric, and now visually we have verified it, but you can actually diff it without that the original file. There a difference between the original file or the one that I have extracted, that it has not been manipulated in between. Okay, then you can use a utility wherein a file is said that these files are identical. There are other ways that you can do a forward hash uh, along with the file. You can pass on the hash, and so that the other person who has received the file should again do a hash on it, and then match the hash matches or not. Okay, so that is another way of verifying the integrity of a file. So this was symmetric, and now let's take an example on asymmetric. Okay, to simulate that, let's first create two folders. I'll just create sender and receiver. Okay. So let's I'm going to change into receiver folder, the directory, and then we'll on a receiver end there are two people now. One is called sender and one is receiver. So what receiver would do? Receiver would generate a key pair, public and private key pair, wherein public key can be shared to the other person so that they can encrypt the message using the public key, which is known to anybody. Okay, and we will as a receiver we will decrypt the message by using our private key. Okay, because we have to secure the private key. It should not be known to anybody. It is different than the previous case when we were sharing the passphrases with the other people. And while if someone is eavesdropping or doing some shoulder surfing or something like that, then the person would be able to know your password and they can decrypt. But in this case, it is considered as far more secure. Okay, so the first step is to generate a key pair. So we'll generate that first. So we say GPG and we say batch, and we use the option generate key, and then we are, rather than giving the file name and writing the content into it, we are just redirecting it from the command prompt itself. And what are we writing in the file? We are saying key type, which key type we want to use, the length of the key, any sub key type, same RSA, and the name, the email, and the password, this is for us. The password is for us and the receiver. Then we have set up an expiry date also, and we would store our public key and private key in a ring, okay, which is called which is given some name, recv pub ring. Okay, you can give any name you want, and then we say EOF we in the file, so it will be able to generate a KBX, like the key ring for us. Okay, and this is the one. So we are in the receiver folder and it has generated a key ring. Okay, now let's get ahead with the next step. So if you want to check the details yourself, so you can use GPT keyring and you can give the name of the keyring and give an option node of default keyring and then list the keys. So if you list the keys, you would get actually only the public key information, its expiry, okay, the algorithm that is used, okay. And you can also look at secret keys like the private key by using secret keys, okay. So you can look at the secret key also and user ID the same. So let's move on to the next step. Now what now you can share your public key by using an email or what do you call that, but before that you have to create export it. Before sending it to the receiver, you have to export that public key from that default keyring or the custom keyring that you have. So we'll just export it with this command. So we specify the keyring name, mention the option as no default keyring, armor, and then output. We want the file to have this name. We mention the export flag and the ID that needs to be mentioned with it. Okay. So then it will create a file called the public key.gpg, and then we need to share this key. So we can have a look at this file. It creates a file called gpg, receive pub key.gpg. Now let's say we have shared this file to the sender, the person who wants to send us a message. So let's copy it to the sender folder and we'll change into that. Okay. So just to simulate that it is being sent, so we'll change it. We ourselves will change it there. Okay. So now the sender has received it. Now what sender would do, in list of its own keys, it will import this key and will establish a trust for further use, and then will while sending a message it will use this key to encrypt it. Okay, so let's do that. So we'll use this command. So we specify the keyring, which is sender pubring.kbx, which is not there on this particular directory right now, but if it is not there it will be created. And then we specify no default keyring and we import by giving the name of the key that we received. Okay, so once it processes it, it will give you that give you a small report. Okay, and it will mention the key and the ID with which it has imported it. Okay, and we can add the trust this user into the trusted list by using this command. Okay, so because while preparing this demo I actually added it into the trusted user, so that's why we are not getting a message called unknown user. So So, but if you get it, then you will get some list of options, like what is the level of trust that you want to put this user in, and or if you don't trust the key, then you can specify those options. Okay. So I actually I had input the option 5, okay, which is the highest trust which you can give a user. Okay, for this, now that the user who shared the key with you, now you trust it as a sender of the message. Now you can encrypt it with this particular public key. Now here you're not aware that what is the value of that private key with the receiver. Okay, so let's use the same example. We'll create a file, and let me close this. So we'll create a file. Oh, yeah. Wait, I think I did not copy it properly. With the same message. Okay, let me mention asymmetric. I don't know. Maybe I have not written the correct spelling. Okay. So we say we've created a file. Let's encrypt it with the public key. Okay. We specify the name of the keyring in which we have imported it. Then we specify option encrypt, and we give the recipient name. So at one time you might be having more than one user with whom you are communicating. So that's why you have to mention this recipient name and the ID with which it exists, and you have to give the name of the file that you want to encrypt. Okay. So it says that it is not certain that the key belongs to the person named in the user ID. If you really know what you're doing, you may answer the next question with yes. Okay. This is just a warning, and then you can say yes, and it will encrypt it. So it's there, right? Same kind of file with GPG. Now you can send this to the receiver. So again, to send it, we'll just copy it to that particular folder, receiver folder. This is the receiver folder. It does not have that encrypted file. Greeting.text.jpg, and I'm going to okay, so it's there. Oh, sorry. Let me just change it to the receiver folder. So let's say receiver has received this encrypted file. Now using its own private key, the receiver would decrypt it. And if you remember, while generating the key pair, we gave the password also. So the receiver should be aware of, should have two things with him, like the passphrase as well as the private key. Okay. So you will specify his own the key ring, then specify pin entry mode as loopback, then passphrase. Now because we are in the same machine, right? So that's why. So we give the passphrase as the passphrase that we kept while creating the key pair. Then we give the output the file name in which we want it. Okay, so we right now we don't have that greetings.txt here, right? It was with the sender, and then we specify decrypt, and we specify the name of the decrypted encrypted file. So it gives you a message, and there is no error which has come with it. So it has created that greeting.txt, and then you can look at that message with the help of any notepad. Okay, so that's these three concepts. With these three concepts, we have finished up the session of for today.